Hello and welcome. This is a debunk video. Now, I had promised myself I would try to avoid making debunk videos because they just take a huge amount of time to put together the necessary information to explain the level of nonsense that flat earthers manage to conjure up from somewhere. This particular video was made by Mark Doxey, a YouTuber, a flat earther, and he directed it specifically at me and has in a chat sections on other people's live streams asked for my feedback. As usual, Mark has managed in the space of 5 minutes to cram in a huge number of false statements, misunderstandings, and just plain nonsense. And as usual, it has taken me a little bit of time to work out the most effective way to respond to this. I could actually respond with a single photograph, but that would probably go completely over his head. So I've made a slightly longer response. I abandoned attempts to make a complete response on the grounds that it was just taking too long, and I didn't think that he would actually bother to watch it anyway.
This video is specifically for Miles Davis. This is my explanation of why ships disappear over the horizon hull first. First of all, though, for millennia it was put forward that the Earth is a globe, and we can prove it by noticing ships sailing towards harbour or sailing away from the harbour. But only until recent years, since we've got better cameras, have people gone out to test this and drawn two different conclusions. Either yes, because of curvature, the bottom of the ship disappears first, or there could be another explanation. This is my explanation. I'm open to criticism. I would welcome any feedback or comeback on this.
Well, I'm glad you're open to criticism, because there will be plenty of it if people actually watch your video. I want to comment on a couple of things you've already said. The observation of ships going over the horizon hull first can be made with the naked eye and has been made for millennia, ever since we've been able to make sailing ships with relatively tall masts. It's also been confirmed, if you like, ever since the telescope was invented, and certainly ships' captains made great use of telescopes to observe other ships at times of war and to look for land appearing over the horizon when they were sailing off and exploring. There has really only ever been one explanation, and it is very brave of you to have put this particular picture on screen. There's really only one explanation for this, and we'll look at that later. You say you've come up with an alternative explanation. I really hope that you have an explanation, that you've thought it through, and that it makes some sense. I have my doubts.
I suggest that all that we see on the horizon is an optical illusion. Now, Travis from The Plain Truth has described this as the ether band. Other channels have described it as dirty air. In the following clip, Rob Skiba demonstrates lensing, where he uses the lens of an overhead projector. He uses a picture of a sun and his phone, both on a flat surface, but looking through the lens you can actually see that the sun appears optically to go down behind the table, when in fact we can see that the table is completely level along with the phone that he's filming it with.
Okay, I will deal briefly with this later on in the video, but just to say here, Well, firstly, what Rob is showing is what lenses do, and not relating this at all to what actually happens in the atmosphere. So what needs to be done is to show that the effect that Rob can produce using a lens is actually matched by what the atmosphere does in reality. And of course, Rob does no such thing. He's also cheated here somewhat. He's picked one particular location for his camera because he knows that that is the one location that will show the effect that he wants to demonstrate. And as I'll point out later, there is a good reason to suggest that this is not an appropriate place to have the camera, and if you do put the camera in an appropriate place, you see something entirely different.
Wolfie 6020 took this photograph. Now,
why have you chosen this? Presumably it's a screenshot from one of Wolfie's videos. Wolfie takes some fantastic pictures, including some fantastic pictures and videos of Bathurst Lighthouse. And you've chosen one that's sort of blurred out of focus and looks like it's taken around about sunset. I'm guessing that you're going to show a flat Earth picture that is equally blurry and indistinct, and you didn't want the contrast to be apparent.
Wolfie is a globe apologist, and he claims that because he can't see the bottom of this lighthouse in the distance, there must be a curve in the way. However, a flat Earth apologist.
Yes, there it is, the blurry flat Earther picture. Okay.
Just follows the steps of Wolfie, positions his camera in the same place, and observes the same lighthouse in the afternoon under different atmospheric conditions.
Well, it was under different atmospheric conditions. I think it was on a different day. It wasn't taken from the same place, nor was it taken from the same elevation above the water. So a direct comparison between the two pictures is not appropriate. I'll explain a little bit more about that later if I have the time.
And this is what he gets. Now, if you notice, the whole of the lighthouse is visible.
Yes, you can see the land beneath the lighthouse, but you can't see all of the land beneath the lighthouse. And so it still isn't an appropriate flat Earth picture of Bathurst Lighthouse.
What accounts for the two different shots? Is Wolfie correct, or is his flat Earth apologist correct? Well, if you can ever get the whole of the lighthouse sometimes, then it's more reasonable to conclude that the Earth is flat and that Wolfie's image is subject to atmospheric conditions. This is a simple example of how a concave lens works, that an image on the left, when it passes through the lens, gets expanded up and down.
A biconcave lens. I'm not sure where you're going to go with this, but are you sure?
As well as left and right. The object that you'll be looking at will be expanded. It will appear larger.
Say what? Did you bother to find out what a biconcave lens actually does? Well, let's push on and see what your explanation actually involves.
So I propose that the atmosphere just above the surface of the water has a lensing effect. So let's introduce a bit of water. And a lighthouse. When the atmosphere has that lensing effect, then the lighthouse increases in size. Notice how...
Pardon? You didn't bother to find out what a biconcave lens does, did you? I could debunk your whole explanation with one photograph at this point. and save myself a whole bunch of time. However, let's play the rest of your video and then, well, we'll look at that one photograph.
The lighthouse actually now dips into the water, the bottom of the lighthouse that is, because of this lensing effect. So now we're going to introduce a viewer, an observer who's looking at the lighthouse, and the image of the lighthouse is being expanded because of the lensing effect. And so the
No. This would have been the simplest thing to do. Just Google concave lenses. Just look at what they actually do. Then maybe study a little harder and find out how they work and what observer would see and why they would see it.
The lower part of the lighthouse actually goes into the water. None of that light, or those light rays, goes directly to the eye of the observer. And this
the only light ray you've got going direct to the observer comes from the central point of the lighthouse, just under where it says principal axis. Oh, jeez.
This is the reason why he only sees the top part, the greater top part of the lighthouse, and the lower bit seems to disappear behind the water, when in fact it's just a lensing effect. Of course, the lensing effect isn't going to happen all the way up the column of the lighthouse. Say the lighthouse is 50 feet high. We're talking about the bottom of the lighthouse, where the ether band is, where the optical illusion happens. So here's a bit more accurate.
You keep saying optical illusion. I'm not sure you actually bothered to find out about optical illusions either, did you? This wouldn't be really an optical illusion, however.
Same thing just happens. The lower part of the lighthouse will dip into the water optically, but not literally. But not only that, we also have the ether band that Travis has been discussing over the past few months.
I thought this was supposed to be the ether band. I thought this was supposed to be an explanation for what the ether band is, that it is the atmosphere behaving like a biconcave lens between the observer and the object in the distance. Travis has proposed something he calls the ether band. He can't tell you what it is. He can't tell you how big it is. He can't tell you anything about how it operates. It's just the ether band, and it does magic. Oh, this drives me potty.
That we're going to have mirroring, and we're also going to have miraging, as well as that lensing. So whatever happens at the lower part of any object that we observe across water will be subject to an optical effect.
And that appears to be it. Okay, well, I said I think partway through that I could demolish this biconcave lens idea with a single photograph. So let's go have a look at that single photograph. Okay, so I said I could demolish the whole idea of a biconcave effect, lens effect of the atmosphere with a single photograph. But I'm going to go into a little bit more detail, and just for the flat earthers out there, let's do some primary school science and maths. This is a lesson plan for primary school science. Class level 5th/6th, so I think that would be 10 and 11-year-olds, maybe 11 and 12-year-olds, not absolutely certain. In this lesson plan, each child should get given a convex lens and a concave lens. And after learning a little bit about refraction, really read this. I'll put a link to the PDF if I can manage that into the description. And flat earthers should read this because it tells them about refraction at a level that possibly they can follow. And there are a number of activities in this lesson plan. the classic straw or pencil in a glass of water that hopefully other people have seen on the internet. And then each child is asked to use their convex lens to magnify text and also to show that a convex lens will result in an inverted image if you hold it far enough away from your eye. And then we come to the biconcave lens, and they're supposed to show that a biconcave lens makes things look smaller. And at that point, this single picture here totally demolishes Mark Doxey's idea that the atmosphere acts like a biconcave lens. At this point, I could just stop the video completely. But I'll carry on a little bit because there are some other things in Mark's video that need to be addressed. The biconcave lens held further away from you, the image is still smaller and still the right way up. And there is plenty of information out there to explain why that is. And Mark, I recommend that you go and find out something about optics rather than publishing videos on YouTube that simply make you look, well, uneducated. So as I said, there's a couple of other little points that I wanted to make about this video before I end. So Mark opens his video with this particular shot of a sailing boat beyond the horizon with its hull and most of its mast obscured by the water. And Mark tried to claim that there are alternative explanations for this observation, one being the curvature of the Earth. The water is in the way, so we can't see the object beyond. And the other being something else. No explanation yet offered at all. And as we've just seen, Mark's attempt to explain it is based on a complete misunderstanding of what a concave lens does. But I'd like to ask Mark why he is so determined to find an alternative explanation for this. If we were looking at a ship, but instead of water between us and the ship, there was a wall, Mark would have no trouble in saying the wall is in the way, and that's why we can't see the bottom of the ship. He'd have no reason to conjure up optical illusions or concave lenses doing magical things or the ether band doing magical stuff. If there was a grassy bank or hill between us and the ship, he'd have no problem in accepting that the grassy bank was indeed between us and the ship and obscuring part of the ship. Yet when there is water clearly in the way between us and part of the ship, Mark and his fellow flat earthers find themselves obliged to come up with some sort of explanation or to ditch their flat earth ideas. It needs to be pointed out that this sort of observation is only one kind of simple observation that can be made here on the surface of the Earth that tells us or confirms for us that the Earth is indeed spherical. There are numerous other ways of demonstrating that the Earth is spherical. I won't list them all here. A little bit of research will find all of them for you. And there is not a single piece of evidence, not a single line of investigation that shows the Earth is flat. Not one in all the centuries that man has been pondering the shape of the Earth. So this is what the camera could see. A lot of this will be out of focus. The camera was set on autofocus and was obviously struggling a little bit with the Fresnel lens in front, but I think you can see clearly what is observed. So the foam block is there in the at the edge of the table, and you can see all of the table right up to the foam block, and all of the foam block you can see where the circle doesn't quite meet up. And as I move that foam block towards the camera, it remains in view all the way up to about here. Now, this is a distance of about 10 centimeters from the lens, and from this point forwards, the bottom of the foam block is going to be starting to disappear. And it does that purely because no light from that foam block can actually get into the lens of the camera, because the lens of the camera is above the surface of the table by a centimeter or so, centimeter or two. And the effect of the lens in between is also going to be further refracting the light coming from that block. But for the best part of a meter, the foam block has remained completely in view. So when we get to about here, this is about 10 centimeters, maybe a little less, from the lens. It will now start to disappear from the bottom up for the reasons explained. Now, this is only happening very close to the camera. Remember, what happens on the real Earth is when things are going far away from the observer, they start to disappear from the bottom up, not when they get close to the observer. Now I've moved the camera back, and I'm moving it back to a point where the whole of the block comes back into view. And this is the location that Rob Skiba used. If you remember from his video, he had his phone camera some distance away from the lens. Now, if the lensing effect is due to the atmosphere, that lensing effect will be occurring right up to the camera. There is atmosphere between the camera and the object in the distance, all the way. It doesn't suddenly stop some distance between the observer and the camera, or sorry, the observer and the object in the distance. So what happens when I move this foam block away now? Well, I repeat exactly what Rob Skiba demonstrated, and that is that it disappears from the bottom up. But of course, and it will reappear from the top down as I bring it back closer to the camera. Now, this effect can be perfectly explained in terms of optics, and I am not going to waste time drawing out lots of line diagrams to show why. If you can't work out why this is happening yourself, then go and study until you can work out why it's happening. So as I said, Rob Skiba was slightly disingenuous because he placed his camera at this specific distance, and it is a fairly specific distance away that will cause this. It has to be a certain distance back for this effect to actually take place in the way that he demonstrated. Now moving the camera back up close to the lens again and moving the foam block away, and we see that the whole of the foam block comes back into view, although the autofocus on the camera struggles somewhat to be able to see it. clearly in focus. So just pause that there. So that deals with part of deals with what Rob Skiba demonstrated quite clearly, I think. So now let's deal with the Bathurst Lighthouse and Wolfie 6020's observation and the flat earthers observation. This is what Mark Doxey had to say in his video.
Be a curve in the way. However, a flat earth apologist follows the steps of Wolfie, positions his camera in the same place and observes the same lighthouse.
So Mark clearly says that he follows Wolfie's steps and places his camera in the same place. Let's find out if that's true. So here is a screenshot from the Flat Earthers video. It shows Rottnest Island and it shows the location of the camera near Fremantle, between Fremantle and Cottesloe. And Wolfie does do a number of his observations from Cottesloe beach area. I believe he has a property there. Now, where did Wolfie take his picture? The one that was used, the sunset picture, the one that was used in Mark Doxey's video and in this supposed debunk video by a flat earther. Well, on that particular day, Wolfie went south of Fremantle to this location here, not up here between Fremantle and Cottesloe, but down here, because he wanted to try to get the sun setting immediately behind the lighthouse. So the distance involved is slightly different. And this is not pointed out in Mark's video. He clearly states that he went to the same place. It's a similar location, but not the same. And distances involved will make a difference to what can be observed. So this is the picture, the screenshot that Mark used in his video. I'm going to show you a few more. The flat earther described their location as a different one to the one that Wolfie used for the shot. This shot is a screenshot taken from the same video of Wolfie's and shows something much clearer as our subsequent shots. So the flat earther was in a different location. The flat earther also used a camera height of 10 feet in their curvature calculations. Wolfie stated that he was at 6 feet. I have my doubts about whether the flat earther really was at 10 feet above the water. I suspect it was a little higher, but that may or may not be the case. The camera heights are not the same. It was not on the same day, so the atmospheric conditions were different, and it was from a different location, closer to the lighthouse when the flat earther took his pictures. So, Mark, you could have used any of these screenshots from Wolfie's video. They are much clearer and much more of the kind of quality that Wolfie likes to produce. Wolfie's done a number of videos about the Bathurst Lighthouse. This is another one, and in which he compares a 6-foot elevation and a 100-foot elevation. I believe this is from Cottesloe, and on the same day at the same time, and showing how much elevation makes a difference to what can be seen. Notice the amount of land that can be seen below the lighthouse when you go to a 100-foot elevation, and the amount that was visible in the Flat Earthers video was only this little piece here. This area is presumably another building or something here. There was a gap here before this next piece of land. So once again, evidence presented in a way that is misleading at best. I'm not saying it was deliberately so. And as I said, putting these videos together is time consuming, and it's time consuming because I actually bother to do a bit of research and present information that is accurate. Mark and Travis, the plain truth, if you want people to take your work seriously, if you actually think you can come up with an alternative explanation to Earth's curvature for the observations that are made on the Earth's surface, then please try to actually come up with a hypothesis that will explain the observations. Mark attempted to do this, but he completely misunderstood what a concave lens actually does. At least he's had a go at finding an explanation. He's failed, but that's okay. When and only when you can come up with a hypothesis that explains the observations on that we see in the real world in a way that uses flat Earth as the explanation, can you then be taken seriously. Once you have come up with that explanation, you must then design experiments and tests to try to falsify that explanation. And if you cannot falsify it, then you will build up a body of evidence in support of your explanation. Purely saying that it is the ether band and leaving it to that and saying it's the ether band, funny stuff happens, the Earth is flat, is no explanation whatsoever. The spherical Earth and science has good explanations for all the observations that we make, for all the variations in atmospheric refraction, for all the miraging effects, looming inferior mirages, Fata Morgana, which is a kind of superior mirage, not another kind of inferior mirage. All of these things have good explanations using physics, the behavior of light, and a vast body of experimental evidence to back it up. So if you want a flat Earth explanation to be taken seriously, you must at least have an explanation in terms of light and optics and so on, and then subject it to some form of testing. And only when you have an explanation that can be tested and passes those tests do you have something to bring to the table. Thanks for watching, everybody, and as usual, this has gone on too long, and I've proved to myself once again why it's not worth making debunk videos.